Hi, my name is Boris Petrenko, and I'm from kiwi.com, and today I'm going to be talking about scaling and multi-repository architecture. Just to define what I consider to be large scale, that's basically, this whole data is what we currently have in our product. We have over 250,000 lines of code that includes JavaScript and CSS. Over 750,000 page hits every day, and we do server-side rendering, so we need to mine performance also on the server. We've got 35 internal people and also many external, and we are distributed all over Europe. That includes Barcelona, Prague, Brno, some in Bratislava, etc. And we solve basically all the problems you could solve in a front-end project. Internationalization, white labels, theming, and all the other things that are listed there. You think of it, we solve it. Why multi-repository architecture? We actually found that it's a lot easier to deal with many smaller repositories when it comes to actual applications. Because it eliminates all the problems that come with a large application, and those problems are often not present in open source projects such as Table or React that go with monorepo architecture. We had a very slow CI, that means like 35% and more for 35 minutes, sometimes even like almost an hour. And we were able to reduce it to something under 5 minutes, including all the tests, build, release, etc. We had a very large dependency overflow. Our yarn install was taking almost 3 minutes, and our bundle was insanely large. And this was just because we different pages like search, booking, and all other pages that we have. They solve different problems, and they needed different dependencies. And also, of course, scripts and configurations, dealing with Lerna and managing the huge repository not to have everything slow and clunky. And having many smaller repositories handled by smaller teams actually allows a certain level of freedom that's related to dependency overflow, that different teams can choose their preferred tech stack regarding dependencies. For example, we have teams that use Lodash, and we have teams that use Lambda, and also the same with data functions versus moment. So it also makes people happy, and happy developers are productive developers. And how to actually pull a multi-repository off? Just extract common stuff into an npm package. You can check our shared functionality package is open source. You can check it out. There's a link later on. And just for any data fetching, for example, translations, any configuration, we have a CLI that does that. It was in our monorepo before, but it's in the repository now. And all the other teams just install it as a dependency, and they just call the CLI and download stuff, use the CLI. And any common components, for example, navigation bar or cookies banner, and any common components are there. And make sure that your teams actually use the library. It's really important because they will find any missing functionality bugs, and it's a lot easier to manage shared functionality library if they also contribute, not just file issues, because that's a pretty large overhead. And also enforce a protocol just to maintain some consistency, so different people can switch teams and it's not that much of an overhead. But as I said before, it's good to allow them to choose their preferred libraries. For example, our protocol means that every project needs a full fault type coverage, test coverage, and needs to be based on React. And when it comes to scaling, what we do is we enforce robust static analysis. We had a very large problems with implementing new functionality in the past year or so, because everything grew like really quickly. We went from 10 developers to like 35 plus in a very short time, and things started to break more often than we actually did releases. So we enforced a very strong ESLint rules, flow coverage, as I was saying before. We started doing many unit tests. Currently we have over 2,500 unit tests. We enforced prettier, which just makes things pretty. There's no reason why not to use it. Just build a solid foundation and make your static analysis number one priority when it comes to maintaining the code base. And all in all, frontend is just Legos. It's just building components wherever you choose, like in Angular, in React, and Vue. You just build stuff. And from smaller things, you build larger things, and if you don't make anything wild in them, they just compose pretty nicely, so there's no reason why you shouldn't scale pretty much effortlessly. Just remove any hacks and be strict in code reviews, and compose those small functions together. And the takeaway point is just that multi-repository architecture is really good, mainly in the way that it removes unneeded complexity of larger code bases. You centralize common functionality into an NPM package, and then it's really easy to pull a multi-repo architecture off. And scale by enforcing strict static analysis and compose simple functional building blocks. Here's our link to our NPM package that contains our functionality shared, and this is my open source project that's a base for our actual applications. That it contains like build stuff, flow, ESLint, etc. That's it.
Thank you. So if we have questions, we do questions during the networking. So. So the next guy from Roy Hunter, actually it's his debut. I was told, yeah, so if something goes wrong, like, be patient, please. I don't think so. So thank you very much. What's your t-shirt size? Because you're
XL.
XL, okay. I was not prepared for such developers. So let me see. XL, M, S, M, M. Let me check. Oh, you can wait.
Yeah.
XL, well, that's one. Hopefully, there's no more big guys.
Videos are increasingly popular format online, and as a marketing platform, as a good one, we sure needed one, and so we decided to build it. And our editor is based on HTML, not Canvas, and it's able to produce either interactive HTML banners or bake them into video. Unlike our competitors, we allow our users to customize the video and play it at the same time. There is no separate configure and preview mode. That's important. It's not that easy to do it. To do the animations, we obviously had to manipulate the DOM, which is what basically every React guide tells you not to do. And if you do it, you should use something they call uncontrolled components, which is quite a broad term. And it can mean, one of the common usages is that you simply render your component, you always return false from ship component updates, and after that, there are no more updates. You can grab a ref and do whatever you need to do with the DOM. That works well with some third-party libraries that weren't built to work well with React, but as I said, prevents from further updates, so that's not really useful for us. For the animations, we decided to use an amazing library called GreenSub. It defines the animations by keyframes, put on some timeline, and the library interpolates between the frames, applying the changes over time. But there's a catch. It doesn't have any concept of initial state. It simply takes whatever the element looks like now and applies the desired changes. Then that means that if the element looks different, it doesn't care. It just doesn't reset. And don't get me wrong, it's not a bug. It's actually a feature. It allows us to combine those animations, simple animations, into more complex ones and create really good motions and stuff. But it doesn't play well with React, so we needed a way of restoring the initial state. And to remind you, the UI allows users to change things while they are moving, so it can easily happen that the element is out of the initial state. Let's say a user decides to use fade-in animation, but while the animation is playing, they change their mind and switch to slide. And because we can't reset, we are left with sliding half visible box, which is obviously bad because it looks bad, and what's even worse, it depends on the time when the change happened, not on the parameters. And there comes another catch, this time with React. As you all know, React uses virtual DOM to store results of your render component, render methods, and compares those between render classes to see if something changed. But the thing is, it never really checks with the real DOM. So if you touched and mutated your DOM, React doesn't know, and you have no way of telling it to parse it back or somehow fix that. And as a possible solution, we tried using snapshots to somehow store the state, but that didn't work well. And if only there was a way of re-rendering the component when we know that it has changed and React doesn't. It turns out there is exactly that. The reconciliation algorithm uses a special prop called key, and you probably know it from rendering lists where you give each item its own key, and then React knows which is which, and doesn't need to throw it all away and re-render it, which is exactly what we need. So in certain cases, when we need to really throw away the DOM element, not just patch it as usual, but replace it rather, we change the prop, the key prop, and get a full render. That way we can reattach the animation, and everything is really predictable and stable. Obviously this is a hack, sure. It's not officially documented. It's merely a side effect, and it may even get lost over time. I mean, it can be gone from the logic, but it can be really useful when you have to touch the DOM, as we have, because of the animations. And if you do it correctly, you can even avoid the performance drop, because in our case we only use really flat components. They typically render just one div and that's it. And we only change it when the animation changes. That typically means some sort of hash, and that is basically it. It's not that big of a deal, but it gets our stable results, and our users are happy. And that's all from me. Besides the editor, we built a bunch of other interesting stuff, front-end, back-end, infrastructure, operations, whatever. And if you're interested to hear more, you can find me up and we can talk. Thanks.
Thank you very much. Well, actually, it was really good.
Thanks.
So I think now it's I don't know. What was the third one? Let me check. I think it was Rafa. Yeah, it was Rafa. So I don't know. I heard one joke. It's I was talking with my guy who was doing stand-up, and
So hi, my name is Rafael Korbaš. I'm from VacuumLabs. I'm here to tell you about how we made the first lightweight wallet for the cryptocurrency Cardano. Well, so what's Cardano? Actually, it's not just the cryptocurrency itself. It's also the distributed computing platform that runs the blockchain for the data, which is the cryptocurrency. Currently, the project is still in its early stage called Bootstrap Era. They launched in September 2017, and the Bootstrap Era basically means that it isn't fully decentralized. The nodes that validate the transactions in the Cardano blockchain are controlled still by the Cardano Foundation. But despite of being so young, it consistently ranks amongst the top 10 cryptocurrencies regarding the capitalization. So why do we particularly like Cardano? First of all, it has strong credentials. The development or the Cardano Foundation is led by Charles Hoskinson, former co-founder of BitShares and Ethereum. So it's a huge name in the field of crypto, and also he managed to gather around him a community of scientists in the field of crypto willing to do research for Cardano, which is exceptional in the among the cryptocurrencies, which are mainly led by engineers. So, as I said, they have a scientific approach to the development. The core ideas are researched and published as papers by the researchers and reviewed by the scientific community. One of those ideas is proof of stake, an alternative approach to proof of work, which is the core concept around the current mainstream cryptocurrencies like Bitcoin or Ethereum, and involves a lot of computations. This is an alternative approach that would not consume that much resources. And let's talk about the main point of the presentation, which is the wallet. Until we launched our wallet, your only option and part of holding Cardano on an exchange like Binance or Bittrex was to have the currency in the official wallet called dataless. Basically, it's an Electron app, and it runs underneath a full Cardano node, so it stores the whole blockchain. As you can see, it has quite a nice interface. They really paid attention to the looks of the app. But the drawbacks would be obvious right after installing it. For example, the syncing takes like 3 hours or 4, and it downloads lots of gigabytes of data. And if you look at the dependencies, as you can see on the left image, it's really quite a lot of dependencies for such a sensitive application. So to sum it up, Daedalus has lots of dependencies. It's slow at, which is a usually attack vector. It's slow at syncing the wallet, and it's based on Electron, which is notoriously vulnerable, and stores gigabytes of data, so it's really heavy. And currently supports only Windows and macOS, so no mobile or Linux support. Well, it actually has a Linux version, but it isn't stable. So we decided to come up with our own wallet. We reverse engineered the Daedalus, since the documentation wasn't really complete, so we couldn't go just by it. And it's web-based, so it's platform agnostic. You can run it on mobile phones. It's aiming to have minimum dependencies. We based it on Preact, which is a lightweight version of React. It's really fast at syncing. It's a lightweight wallet, so it basically interacts just with the blockchain explorer, and it takes just seconds to fetch the relevant data. It doesn't store any data permanently, so once you close the window in the browser, the data disappear, and it's backwards compatible with Daedalus. So even if you had some problems with our wallet, you can fall back to the official one. Here's a quick preview of the functionality of our wallet. As you can see, it's as easy as putting the memory in a field and it loads. Here we pick an address and we are going to send funds to ourselves. You can send either the maximum available amount or you can type any smaller amount. So now we are submitting the transaction. It's confirmation deal shows and it takes like 30 seconds to submit the transaction. It means to submit the transaction to the confirming node and to wait for the blockchain explorers to actually show the transaction. Okay, so once we go back, we can see that the balance decreased and the transaction appeared in the history, is the last one. And here we navigate to the blockchain explorer to see that the transaction actually appears there. Another functionality that we implemented is exporting the wallet as a JSON, so we don't have to retype the memory each time we log in. It's also a feature too from Daedalus, so this export is compatible with Daedalus. Okay, so we downloaded the export and now we are logging in, typing the password that we used to encrypt the file. So as you can see, it's a fully fledged wallet for Cardano. Basically, has all the core features that you need for a wallet, for a cryptocurrency. And regarding future work, Trezor hardware wallet is coming very soon. Hopefully we will meet even the official Cardano developers, which are working on Ledger Nano integration, which isn't ready yet. And our implementation already was reviewed by the Trezor developers and approved. And now it's waiting for the next firmware release, which will happen probably in the next month. We are also planning on supporting testnet for Cardano, which will be launched soon by the Cardano community. And we would eventually like to replace the blockchain explorer with a more effective, efficient backend. And so the requests are faster. And also we would like to eventually support signing transactions offline, just like in Minder wallet, which was actually our source of inspiration. A few disclaimers to conclude. The official Cardano team did not review our code, so take it with a bit of caution. We are still in the alpha stage. Hopefully we will go to the next stage once we will add the Trezor support, which will be another level of safety. And well, I think that our wallet is a good starting point for you if you would like to do a similar project for another cryptocurrency or even for Cardano. You can look at our source code on GitHub. The site is atellite.io, and also you can reach us by email atellite@VacuumLabs.com. So thanks.
Now I would like to welcome Vojtech Mašek on the stage from FlowUp. He didn't test this presentation beforehand, so there is 50% chance you haven't recorded.
More than 50.
So the stage is yours.
Great. So this talk will be about generating type-safe API clients for the front-end. Why should you care? Because you can have same backend and front-end models. You can have API documentation, API boilerplate based on your documentation generated, so you don't have to write it. You can have code that is always up to date, and devs can then start working on your applications like really soon and in a really efficient way, because all models and all API structure is prepared for them from the documentation that in this case will be OpenAPI or Swagger. So there will be no model or API related errors in our applications. Why? Because compile error is always better than runtime error. If compiler can fix it, then or catch it, then it's a lot better than if you found out in production. So we are using OpenAPI specification. That's a normal YAML or JSON file. I think a lot of you have already seen it. It describes the whole API, everything from data types, API methods, a lot of stuff. So R2 API client generator is easy to use. It generates data models. It generates API model functions, method functions, pardon, and it can be used in pipeline. It will generate a lot more than this, and in future it will be generating more. For example, we already are discussing feature proposals for generating a mock backend, for generating mock data, for generating default data values, for generating ORM for application, and these will be implemented, I hope, soon. And in pipeline, that means it is lightweight. It is written in TypeScript, so you just pick it from a Node npm repository and run it in the pipeline. So every time something changes in your Swagger file, it gets regenerated, and if there is an error, your build fails. So everyone will know in your pull request that it failed and it has to be fixed. No one will notice in production. How it will look? So I've picked an example from GitHub. That's issue. So issue has some assigning body labels, milestone, title. It can have more, it can have less. It looks somehow like this. There's also user. User has ID, name, and role. A role is generated as enum, and it picks a role from this enum when you are using it. So this is the model, and this is the API method function. This is how we get all issues from GitHub. You can just call a function that get issues. We pass arguments. There are some examples. What can you pass there? The filter state and so on are required. Since is not required, and all the comments and everything is also generated. The main thing you can notice is the observable with the template generates that shows you what will be returned. So in this case, it will return an array of issues. So you can be sure that what you get from backend will be this, and you can then click it, see how the issue looks, and just use it in your component. So what is our goal? Our goal are happy developers, no runtime errors, and quick and reliable way to develop. Because with this, you can really focus on the thing that you are doing, and that's developing the business logic, the thing you are like they pay you for that it works, not that you are fixing stuff. So sorry, it got back, but this is link for the tool. You can start using it. Currently, we support only TypeScript with Angular API client, but for future we'll be releasing an solution for React and Vue. So have a look, and also if you know about something that should be included, then definitely tell us any issues. If I have time. So it is currently used in production. We are using it on 6 projects, and I have few contributors that all have it in production in financial applications. Why you should not worry about using it in your project? because when you generate it, it generates code. So if you don't like something or if there is a bug, you can just fix it, tell us about it in issue, and hope that we will be fixing it soon, or put pull request there, and I will merge it as soon as I verify it's correct. So that's why a lot of people start picking it up, because it's a lot faster than its like competition, where you have to wait a very long time, because it's like strongly community driven, and no one is probably using it in production because it's written in Java. So, thank you.
Now I would like to welcome Kuba Švehla. Actually, he brought all his friends to win this thing. Only thing that he got only 2, so no luck there.
So, hello, my name is Kuba Švehla. I'm a programmer in a small company called FaceUp. We are like 3 programmers, and we are trying to have the most bleeding edge stack. So we really love JavaScript. We have Node.js on backend, React on frontend, and we really don't like tests, because if you are only 3 people in a company, you don't have enough time to write tests. Okay, and my topic is how to avoid undefined is not function. I think that everyone who program in JavaScript know that error message. So, this is a basic example. I have some function, it's clever, it takes some human. I will ask if that human has brain, and if he has brain, that guy is clever. But problem is when I will ask, is clever with undefined? Because that function doesn't handle it, and it will false with runtime error, and as Vojta said before, write times error aren't the best. So, what now? We can write a unit test, but as I said before, unit test, you have to sync your test with your application, takes too much time, so that's not the right way. Maybe static types. And we have another function, and this function is really beautiful. You will define shape of human, you can ask to some properties, and if you will say, has he friends, it will fall in compile time, and compile time is still much better than runtime error. So this is nice, but there is one big problem, and it is that you have to write types. It's beautiful because it's self-documented, but still you only 3 programmer, small company. So come to next slide. Well, this is a React application. Everyone knows Redux. Everyone knows Redux. So this beautiful application, a lot of reducers, actions, everything is awesome. A lot of REST API endpoints. And what do you think? How many places you have to define for prop types, and you have to write types interfaces and stuff like that? There. So we have to define types for this. And if there are only 3 people, as I said before, it's really hard. So Redux is not the best option. So, because it's lightning talk, I have to introduce GraphQL like in 20 seconds, so it will be quickly. Is there anyone who knows GraphQL? Wow, cool. So for the others, GraphQL is like REST API on steroids. And you can define some shape of GraphQL, not like in REST. For example, you will define, hey, there is name is string, or there is age is number, and it's like ORM model in database, but it's for API. Okay, so we will define API of your backend. And now we will try to switch our mind to another dimension and start to think that we have a still single-page application, yeah, SPA. But what if we will try to sync the whole state of our application with server? Not like in Redux, but whole in server. So that means that every state of our application, every props, every data will be synced with server. There is small box, it's called relay store, and at the moment we don't care about it. It works like cache or something what will make our application fast, but it's not necessary to understand what does it mean at the moment. So each of our React component will be synced with GraphQL server. Okay, and what does it mean? You still have to define prop types or type interfaces with Flow or TypeScript, but this is perfect state for us. We wouldn't like to define it. And is there some option? Yes. So try to imagine that you will take these GraphQL static types, as I said before, you can define, for example, name string, and you will generate types to your application component. And because every component is synced with server, it does mean that server has types and he can reproduce it to your React component. And we will show it on a real example. So this is my simple component. As you can see, there is some viewer ID. It's H1, yeah, that. And there is a request to my server. I will ask my server, hey, give me some viewer and his ID. If I will ask, for example, viewer STRV, it will trigger a flow error. Yeah, come on. Yeah. It will trigger error that STRV doesn't exist. For example, row, still the same error. But if I will ask my server, hey server, could you give me ID and role, save it, and run that compiler who will generate me types to this code, it works. No error. And this perfect website, you see, it's role. And if I will look at type definition, which is generated, you can see that there is viewer has ID and role is of type user role, and user role is some enum. So it's perfectly typed component with only these lines of typing, but this will only join our generated type with our components. And I will do it again, for example, email. I will define email in our schema, generate new types, and write. And it works. Ta-da! So this is perfectly typed. And if I will write some shit there, it will not work. You see this error. So, and this is awesome, but it's hard to have GraphQL schema if you are old IBM company. So the question is that ready for production? And I say yes, we are using it. We are only 3 people using it, and Facebook use it too, because all of these tools are from Facebook. So yeah, just try it. It's awesome.
So now I can back to
Hello everybody! My name is Vojtech, and I'm gonna tell you something about my experience with drag and drop and building interactive UIs. Because drag and drop, everybody loves it, right? Cats love it. Humans love it. You know, everybody understands it. Even your grandpa knows what to do. We in Product Board, we especially love this interaction, and when we were thinking about implementing new features using drag and drop, we went to NPM and we found a lot of packages. We've tried some of them. For example, React probably one of the first drag and drop libraries in React. It's nice, it's well documented, hackable, but we couldn't use it because it just doesn't allow us to do a really delighting experience for our users. So we tried React Beautiful DND. And yeah, it's beautiful. Like if you want to build a new Trello board, you can do it like in a matter of seconds, but like we couldn't use it because it was too opinionated. And once we wanted to build something better, you know, it just wasn't possible. We also tried D3, data-driven documents. Great thing, but we couldn't use it because we just didn't feel comfortable introducing whole new technology into our dev stack. You know, we are React guys and we want to build things on top of React. So what are actually our needs? This is a roadmap. It's part of Product Board. And what do we need here? Okay, so dragging some cards, dragging columns, and at this point you could argue with me like, okay, so we can build it with the React Beautiful DND, right? It's the use case. Well, not really. There's like something more we want to achieve. There are some custom visualization, and look at these beautiful animations. You can hide things, it moves. You can switch to different view, and yeah, look at, you know, we are scrolling the board and the titles in the blue bar are just perfectly aligned with the edge of the screen. If you collapse things, you know, everything moves, and like this is really important for our customers. Like we really believe that it makes their work much better if they really see the feedback on what they do, and also like it's much more enjoyable to work with such tools, you know, instead of something like you click and you don't know what happens because it's instantaneous. So yeah, that's the use case. And what is the trick? Why the animations are so nice and so good in quite complex world? Absolute positions. Let me explain. So this is the code. On the left you see a little bit of the board. On the right there is the code. And the trick is that you just know exact X and Y coordinate for each of the cards. So when you drag, you just update the X and Y coordinate and you basically style it with Translate 3D, and then all the animations are handled for you by CSS, the transition property. And what's even better, like now I'm scrolling and the elements start to disappear. Like why? Because, you know, the cards are not on the board, so you just don't need them. You don't need them to be rendered. Our customers sometimes they have huge roadmaps. And this is one easy way how to make the performance much better. And once you know the coordinates, it's just so easy to decide whether to render it or not. Well, at this point, I would really love to announce that we are open sourcing it, but yeah, we are working on it. Give us some time. Actually, we have two packages that we are now using internally. One of it, we call it Draggable Canvas, and it's like a React component wrapper that helps you with the drag and drop interactions. Another one, we don't have a name yet, but it helps you generate the positioning, you know, because in some complex UIs it can be quite hard to calculate, you know, the XY position of each element. So we basically re-implemented some of the box model you know from CSS into JavaScript, you know, and yeah, that's how it works. Yeah, we want to announce it at the Reactive Conference 2018 this year in less than a month. And yeah, now I would really love to ask you for a feedback. Like, what do you think about it? Some ideas. What's your experience with drag and drop? and whatever. Just let's talk, after this announcement. Yeah. Thank you very much. Also, you can follow me on Twitter. You can follow Breakboard or check the breakboard.com if you want to know what we are building. There are much. This is really nice. All of it.
Thank you.
Thank you.
The teacher. And then we got like last one, Konstantin, Lebedev from STRV. He's coming stage. Well, as I'm looking, I don't have to check for it.
That's okay.
I can give you that one.
Hi guys. So today I want to talk to you about the way we build user interfaces and how we do it in a smart way. So to get started, let's think of an example. Let's say we want to build a weather application, right? So we find an online API that returns the JSON data, then we pass the JSON data down to our React components, we go to the browser, and we see the result. So everything is working, right? Now that we are good developers, we want to make sure that our UI works properly for any set of data that we receive. So today we got cloudy, but what if API returns sign? How can we handle that? And since we don't have any control over API, and API returns data only for one day, there is not much we can do except for maybe wait for a couple of days for a sunny day to come. But that's probably not the smartest way to go about it. And so instead we can just hard code the value, and go to the browser, see the result. And everything's working. So at this time, we are really happy with the results. We go on, we start working on different parts of the application, and we completely forget to remove the hard-coded value. So in a couple of weeks, we get something like this. Or even worse, our client gets it. And this is one of the problems with UI development when we need to test multiple visual states of our components, but the data that we receive from API only allows us to test one state at a time. So let's look at a different example. Let's say we want to build an onboarding flow or first user experience, whatever we want to call it. So this is what it looks like. User goes to the first screen, they get some general information about the app, they click next, they see the second one, they go to the final one, and we realize that there is an issue, there is something misaligned on the last step. So what do? We go back to the editor, we check the code, and looks like it's a padding issue because, well, to be honest, nobody probably remembers what is the proper order for the padding. So we tweak them, we rearrange, and we have to go back to the browser. And yeah, basically we have to go through the entire flow once again, and now we see that it's misaligned but on a different side. So this is very frustrating, but at this point, all we can do is just go back to the editor, change the value, click through the entire flow again. And that's the problem number 2, that sometimes we need to test multiple visual states. We need to test visual states of a component that is not immediately visible on the screen. So we basically have to click through the entire application flow just to get this one component to show. And to solve these problems, we can use a tool called the Storybook. So Storybook is an isolated environment to quickly develop and design UI components. So isolated here means 2 things. One is that our Storybook with our stories lives as a separate React application and it doesn't interfere with the main application. And the second part is that we don't have to render our entire application, we just render the components that we actually care about. So how can we get started with it? Well, it's pretty simple. All we need to do is install the CLI, then run git storybook command. It will inspect your project structure. It will see if it's a React project, a Vue project, or Angular, or wherever. It will fetch and install and configure everything needed to run the storybook. So then you just execute run storybook commands, and you get this nice empty interface. So there is nothing to see here, so we need to add our first story. Going back to the first example with the weather app, this is how we can define stories for it. So let's say we know that the data we receive can have 3 distinct states. The weather can be sunny, cloudy, or rainy. And this is what we do. We basically define 3 different stories, which is a bit of a fancy name, but all we do is just define our render functions, and we hardcode the values. Now, here, hardcoding values is perfectly normal because it's not our main application, it's just some separate development environment, so doing this is just okay. So when we do that, our storybook now looks like this. So on the left, we have our story type that groups different stories, and in the main area, we can see the actual component. And this approach also solves our second problem with the having to click through the long flow just to get to the component. Because when we work with storybook, we don't need to render full flow of the application. We just render each step as a separate story. So every time we make a change in the editor and we go back to the browser, we see immediately just the component that we're working on. So to summarize, using Storybook, we can test components in isolation. We can cover as many visual states of component as we need. And it also will serve as a light documentation for our UI, which is another problem that I have not mentioned, but if you had to onboard a new developer on a front-end project somewhere in the middle, you know what I'm talking about. Because everybody has to learn what components we have, what is the logic there, and Storybook serves as a light documentation for it. And that is how you write the components the smart way. Thank you.
Thank you very much. That was our last speaker. So, how are we going to figure out this story? So the winner of today gonna be enlightening spot at Reactive.com. Actually, for those of you who wanna come to Reactive.com, there's like 30% discount on current price tickets. You can use LT Cup, and you will get like 30% discount. So now, if you could, like the guys who haven't talked today, so if you could come to the stage, so in here. So thanks to Boris Petrenko. Šabata. Korbaš. The second one was Vojtech Mašek from FlowUp. Kuba Švehla. Vojtech Prikryl. And Konstantin Lebedev. So how are we gonna vote? So please go to your mobile phones or computers and put their like slide.do and through the web browser you put their slide.do and use the hashtag Breno, and there you should be able to see all of the talks and guys and just vote for one talk. And then we're gonna show who's gonna win today. You can vote for yourself if you want. Okay, that's okay. Okay. 30 more seconds. So, did you get it? Like, it was understandable.
Slide the dough in web browser, use hashtag Brno, and you should join it, and there should be like 87 talks, and you can hold on for them.
Just slide your results. Login. And the winner is, or I can like hide it. Anyone like still voting, or like did you finish all? Okay. So, and the winner is, okay. The winner, the winner is Kuba Švehla. So you won the lightning spot at Reactive Conf.
Yeah,
So-
thank you.
So some like,
You want to say something?
I want to say thanks to my mom. You know, I invited half of it, people to vote me, so. But thanks.
so for the rest of the night, like there's beer, you can enjoy like network, and I think the pizza will come in like 5 or 7 minutes. So just wait and hang out, and thank you all for coming. Hopefully you guys.